My dear students, welcome to Amines part 6. In this video, we shall be studying about physical and chemical properties of amines. Let's begin with physical properties of diazonium salts. Benzene diazonium chloride is a colorless crystalline solid. It is readily soluble in water and is stable in cold but reacts with water when it is warmed. Benzene diazonium fluoroborate is water insoluble and stable at room temperature. Now let's discuss about chemical properties of diazonium salt. In this, first one, reactions involving displacement of nitrogen. Diazonium group, being a very good leaving group, is substituted by other groups such as chloro, bromo, iodo, cyanide and hydroxyl, which displace the nitrogen from the aromatic ring and nitrogen gas leaves away. Further, Sandmeyer reaction in which diazonium group can be replaced by chloro, bromo or nitrile groups. The chloro, bromo and nitrile nucleophiles can be easily be introduced in the benzene ring by the reaction of benzene diazonium chloride with cuprous salts. And this reaction, students, is known as Sandmeyer reaction. When benzene diazonium chloride is reacted with cupric chloride in presence of hydrochloric acid, formation of chlorobenzene with the liberation of nitrogen occurs. And when benzene diazonium chloride is reacted with cuprous bromide in presence of hydrobromic acid, formation of bromobenzene occurs. In the third case, if benzene diazonium chloride salt is reacted with cuprous nitrile in the presence of potassium cyanide, the formation of cyanobenzene occurs. In all the three reactions, it is clearly observed that diazonium group from benzene diazonium chloride is replaced by chloride, bromide and nitrile to form the respective products. Let's discuss about Gattermann reaction in which replacement of diazonium group occurs by chloro, bromo or nitrile groups. Chlorine or bromine can also be introduced in the benzene ring by treating diazonium salts with corresponding halogen acid in the presence of copper powder. Then this reaction is called as Gattermann reaction. Let us consider reaction when benzene diazonium chloride is reacted with hydrochloric acid in the presence of copper powder. It forms chlorobenzene with the liberation of nitrogen vapors and cuprous chloride. In second reaction, when benzene diazonium chloride is reacted with hydrobromic acid in the presence of copper powder, it forms bromobenzene with the liberation of nitrogen and cuprous chloride. In both the reactions, students, diazo group is replaced by halogens, chlorine and bromine in the presence of copper powder. Now let's consider replacement of diazonium group by iodide. Now let's consider replacement of diazonium group by iodine. Diazonium salt solution on reaction with potassium iodide gives iodobenzene. Let us consider reaction for this. When benzene diazonium chloride is reacted with potassium iodide on heating, it forms iodobenzene with the liberation of nitrogen vapors and potassium chloride. Now fourth one, replacement of diazonium group by hydrogen atom. That is nothing but, students, reduction of arene diazonium ion. Mild reducing agents like hypophosphorus acid, which is also called as phosphinic acid H3PO2, reduces the diazonium salts to arenes and gets oxidized to phosphorus acid. Let us consider reaction of benzene diazonium chloride with hypophosphorus acid, which is also called as phosphonylic acid, in the presence of water to form benzene with the liberation of nitrogen vapors, phosphorus acid and hydrochloric acid. In the second reaction, students, we are using a different reagent to bring about reduction of arene diazonium ion, and in this case also replacement of the diazo group by means of hydrogen atom occurs. Ethanol reduces diazonium salts to arenes and gets oxidized to ethanol. Let us consider reaction when benzene diazonium chloride is reacted with ethanol. The formation of benzene, ethanol, hydrochloric acid and nitrogen vapors occur. Fifth reaction, that is replacement of diazonium group by fluorine atom. When benzene diazonium chloride is treated with fluoroboric acid, that is HbF4, benzene diazonium tetrafluoroborate is precipitated, which on heating further decomposes to give fluorobenzene. Let us consider reaction. When benzene diazonium chloride is reacted with fluoroboric acid HbF4, it forms benzene diazonium tetrafluoroborate, which on further heating decomposes to fluorobenzene, that is C6H5F, and boron trifluoride with the liberation of nitrogen vapors. Next, replacement of diazonium group by OH. Aqueous solution of benzene diazonium chloride on heating undergoes hydrolysis to give phenols. Let us consider example when benzene diazonium chloride is reacted with water, formation of phenol, hydrochloric acid and nitrogen occurs. In next reaction, students, we shall be studying about replacement of diazonium group by nitro. When benzene diazonium tetrafluoroborate is heated with aqueous sodium nitrite solution, in the presence of copper, the diazonium group is replaced by nitro group. Let us consider reaction of benzene diazonium chloride with fluoroboric acid. Benzene diazonium tetrafluoroborate is produced, and when this is further reacted with sodium nitrite in the presence of copper on heating, it forms nitrobenzene. Next, we shall be studying about reactions involving retention of the diazonium group, that is azo coupling reaction. Benzene diazonium chloride reacts with phenol, in which the phenol molecule at its para position is coupled with a diazonium salt to form para hydroxyazobenzene. Let us consider reaction of benzene diazonium chloride with phenol in the presence of a base. It forms para hydroxyazobenzene, which has an orange color, along with hydrochloric acid. In this reaction, students, if you observe, diazonium group has been retained in the product. So this reaction is called as azo coupling reaction. Let us consider one more reaction which also involves retention of diazonium group. In this, benzene diazonium chloride reacts with aniline, in which the aniline molecule at its para position is coupled with the diazonium salt to form para amino azobenzene. Let us consider reaction for this. When benzene diazonium chloride is reacted with aniline in the acidic condition to form para amino azobenzene, which has yellow color, along with hydrochloric acid. In this reaction also, students, diazo group has been retained. Thus, it can be called as azo coupling reaction with the removal of hydrogen chloride. In the previous two reactions, two benzene rings are joined through an azo group called as N double bond N, thus referred as azo coupling. These azo products obtained have an extended conjugated system having both aromatic rings joined through N double bond N bonds, and these compounds are colored and can be used as dyes. Importance of diazonium salts in synthesis of aromatic compounds. The replacement of diazo group by the groups such as fluoro, chloro, bromo, iodo, nitrile, hydroxy, it is very helpful in preparing those substituted aromatic compounds which cannot be prepared by direct substitution in the benzene ring or by using substituted benzene. Now let us discuss some of the uses of amines. First, low molecular weight amines are used as reagents in organic synthesis, solvents in laboratory and industries. Third one, intermediates in the manufacture of medicines. Second application, quaternary ammonium salts are used as detergents. Quaternary ammonium compounds or quats are effective sanitizers. The active ingredient in this type of product is a mixture of compounds that would be noted as alkyl dimethyl ammonium chlorides. Quads can be used to both clean and sanitize a surface. Third application, aromatic amines like aniline are used as in manufacture of dyes and drugs, that is medicines. Second, as additive, antioxidants and vulcanization accelerators in rubber industry. Third, for preparation of phenyl isocyanate needed for the preparation of polyurethane plastics. Thank you, students.